Hope all is going well where you are. All is going well here. It is chapter 9, worksheet number 6 is when we start the really awful part of this chapter. So we're going to start that off by doing the world's easiest problem. Problem that where, oddly enough, probably about 3rd grade, you did your first calculus problem and you were never told. And so I'd like you to do that calculus problem for me right now. I would like you to go ahead and say I have a loaf of bread that measures 10 inches by 5 inches by 6 inches. What is the volume of that bread? Go ahead and pause your video, and then when you're done, pop it back on, and hopefully everybody has the right answer to this, because we got to go backwards in time if you don't. All right, so you probably did something like, oh, well, that's just, you didn't do that, hopefully. Let's see here, if I find my... There you go. Probably did something like 10 times 5 times 6. If you remember your trig lectures, you know these have to be cross products, and therefore you got 300. And then hopefully remember that your teacher at the time told you do inches times inches times inches, which is inches, 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 or inches cubes. But it's actually more fundamental than that, because what you're talking about is if I slice this piece of bread up, I could make 300 little inch cubes, 300 of them, right? And so that's intellectually what we're doing, right? We look at this problem, we go, all right, I have here a 6 by 5 by 10. If I were to cut this front up 5 ways this way, 6 ways the other way, and I were just to slice off an inch of it, I would have 30 cubes just in that first little bit. Right, 30 cubes. And then if I have 10 inches and I slice it this way, I'd end up with a total of 30 sets of 10, which you're hopefully know is going to be 300 cubes, right? And so what we've been doing since the beginning, when you were first taught how to do this stuff to find the volume, is you said, okay, well, the area is equal to 6 times 5 slices, because the 6 by 5, right? And then you said, and therefore I'm going to take my 6 times 5, which is my area of 30, and I'm going to therefore turn it into, I have 10 sets of those, so I'm going to do 30 times 10 as I walk from the front of the loaf of bread to the back of the loaf of bread, giving myself 300 inches. We're in agreement. So far in agreement. All right, cubed. So now what you're going to do is you're going to do, what if I cut it in half? That should take you about 2.2 seconds. Go ahead and do that. Pause it while you contemplate what the answer should be. And then I'm going to show you a harder way to do the same problem. Now, we did slice this bread in an unusual way. We sliced it from the top front to the lower bottom, right? But it's still cut in half, right? We basically made it 2 loaves that are equal size. We could do that by showing that if we had taken the other piece, like if we'd let's see here, if we had drawn in this other piece, oh, that's terrible drawing, we would have the same size thing, right? By flipping it out and putting it right next to each other, we recognize the same thing. But that is not the way we're going to approach it in just a moment. But that is a way in which we'd approach the problem. We'd say, look, uh-oh, I just erased things I shouldn't have erased. Oh, that's interesting. I didn't know I could do that. Okay, that's good news. Or not good news. Let's see here. Okay, let's see if I can erase without getting rid of the equation, which I could derive later if I needed to. So I guess I probably shouldn't waste time on that. But anyway, so we know it's going to be what? 150, right? So we would say 150 cubic inches, and my life is good. Problem with that approach is, although we rationalized it out, we're no longer using the land of length times width times height. In fact, what we're doing is we're saying, well, it's got to be half. Okay. But if we approach it the same way we did before, we would say, aha, each slice is length times width, so my area formula would in fact be, area formula would be what? My area formula would be the base is 5, my height is, If you look at the side of the bread, we have a distinctive problem. What's the distinctive problem? Distinctive problem is the bread height is changing. For every single end of the loaf, our bread is changing. And so there's no way to actually say what the height is, because the height is going to change as I move a 0.5 millimeter fractional thing to the right. Well, that's discouraging. So I'm going to leave it as a variable because it's going to change, and it's something we don't actually have a value for, so we like that. And then what we should do is we should then take this area formula and we should multiply it by the length this way. The problem, of course, is as I go this way, my height is changing. Well, if I wanted to make a better approximation, what I would do is I'd start slicing these into smaller pieces, right? And use the height of the average height of whatever the piece I currently have is. And then slice that in half would be even better approximation. You know what would be the best approximation? The best approximation would be if I sliced it so thin, the front and the back had no real difference at all. Notice I took the limit as I sliced it to infinitesimally skinny. Do you remember what that's called? That's called an integral. We're going to integrate as we walk from the left-hand side of the bread to the right-hand side of the bread. We're going to integrate as we walk. We're going to call this the x-axis, call this the y-axis. And if I do so, I'm going to be integrating by walking the x direction. Now I have a problem. My area formula that I'm ready to plunk in there is 5y. And I'm going to start at 0. We're going to assume this point here is 0, 0 to make our lives better. And we're going to go to 10. And the problem, of course, is that's a y. So these problems are always going to boil down to finding an area formula. Because it's changing, it's going to be a formula, not a number, right? You can't just use 30 because height's changing, right? And the bigger problem is, since I'm walking in the x direction, I know I'm going to integrate with respect to x, right? I'm walking through my rectangles in the x direction. By the way, these are rectangles. Even as I'm right here, my height's getting shorter, but I've got a shorter rectangle, right? So this formula still works. The problem is y is changing, and it depends on where I'm standing, right? For this rectangle right here, I know I'm standing right there. And so what I'm going to do is I'm going to figure out an equation that relates y and x. And since we all know what the equation of a line is, we would go, aha, y equals, this thing is going down 6 and over 10, right? It starts 6 inches high and ends 10 inches over here. So it goes down 6 over 10. X plus my y-intercept, in this case, would be 6 because I made that 0, 0 down below there. So then I get y equals -3/5 x plus 6. And this is fun. And now I know what y is in terms of x. So I'm going to replace the y with this mess. And I get the integral from 0 to 10 of 5 times -3/5 x plus 6 dx. And I've got the integral from 0 to 10 of, those 5's cancel out, give me -3x plus 30 dx. Agreed, just distributive property, we know how to do that. Raise its power by 1, divide by the power I get. Raise its power by 1, divide by the power I get, 0 to 10. And then I plunk in my 10, and I get -300 over 2 plus 300 minus 0 plus, whoop, my 0 didn't work. Hold on, let me get my 0. 0 plus 0. Okay, and so I end up with 150 inches cubed, just to prove that calculus works. So what's happening here is I am going to, when I have a problem where my area is changing as I walk through my shape, I'm going to have to write a area in terms of a function. And if I'm walking in the x direction, it better be in terms of x. Okay? And if I'm walking in my y direction, this had better be in terms of y. And then I'm going to integrate that area with respect to x from my starting place to my ending place. That make sense? All right, so that's going to be my approach going forward. This is just the introduction. The next piece I'm going to run you through is I have a toy at home, and I'm going to show you my toy, and then I'm going to walk you through how we'd find the volume of that toy. All right, that is not on your worksheet, so you need to pause on the worksheet and just follow along on the home version.